Thank you for joining us. In this session today, we're going to explore blockchain technology, and we're not doing that by ourselves. We have people from Bloxs and from Streamr here. So I'm Michael van der Veeken from OSIsoft Research, and I'm joined by Johan Mulder from Bloxs, and Henri, I'm going to pronounce his last name, trying to pronounce his last name, Henri Pihkala, almost, okay, yeah, from Streamr. So first of all, a tiny little disclaimer. We're going to talk about very forward-looking technology. And OSIsoft, we're not building any blockchain products, but we're really here to start exploring this technology. And this is really a journey of discovery. And that's something that we want to do together. It's not just OSIsoft. It's OSIsoft together with our partners and with our customers. So please don't make any investment decisions or whatever based on this. So the topics of this session. So I want to try to quickly introduce some of the essentials and some of the properties of blockchain technology. It's a complicated subject. I'll probably fly over it, but I want to touch on some certain principles. I'm going to hand it over to Henri from Streamr. And Streamr is a startup company, and they're really focused on creating a platform for real-time data sharing, but also monetization of data. And after Henri, I'm going to give it over to Johan. And Bloxs is really focusing on bridging those real-world scenarios, those real-world problems, and seeing how they can be solved with blockchain technology. And hopefully we'll have some time for questions and a discussion. I know this is the last session before lunch, so we can finish in time. So you might have had a similar conversation like this in your office. There's a Dilbert comic for everything. Really, blockchain is clearly in a hype. There are a lot of articles, there are a lot of promises. But we're all seem to be trying to learn and trying to discover what this technology actually means. And that's what we want to do today. And that's what we want to do as a start of an ongoing discussion. So, trying to explain what blockchain is in a couple sentences and without resorting to technobabble is a challenge, and I still find that a challenge. But the best way I've seen it put is that blockchain is a big trust machine. And blockchain is really there to remove those trusted third-party intermediaries from the process of exchanging value. As you might know, blockchain emerged as a technology from Bitcoin. And Bitcoin really started as an experiment in monetary economy. And really the premise is that it changed our perception of how value is generated, how value is stored, but also how value is transferred. And when we talk about value, we're not just talking about monetary value. We're not just talking about cryptocurrencies. We could also be talking about a digitally encoded proof of ownership to a physical real-world asset. We could also be talking about more intangible value, like votes, intellectual property, copyright, but maybe even data that is valuable to you, to your organization, but could also be really valuable to someone else. So some of the properties that make blockchain an interesting but also very different technology. First of all, you have to realize that blockchain networks are decentralized. And this means that this is basically a big peer-to-peer network where everyone is equal. We're all peers. There's no one that has elevated privileges. There's no one that really governs this network. So there's a level of architectural but also political decentralization in blockchain networks. And there's a difference. Different implementations treat this differently. Different scenarios would also treat this differently. There's also the property of censorship resistant. And this sounds really scary, but it basically means that if you play by the rules of this decentralized network, there's no one that can prevent your actions. If you do something that is valid, if you have a valid transaction, there's no one that can say, I don't agree with that, I'm going to stop this. The other one is the incredible robustness of these blockchain networks. So in blockchain networks, and you might have heard about this, there's this, what we refer to as a distributed ledger. This is a ledger that is shared among all these peers. And the network, the cryptographic algorithms that govern the network, is in control of creating consensus. What is the actual truth of this distributed ledger? But what this means is that these networks are really robust. Even if half the peers or you have a near catastrophic failure in the network, there's still always a copy of that ledger. And you can check that the ledger is correct. And then there's the concept of distributed trust. Some people refer to it as trustlessness. And this really comes down to if you communicate or if you transfer or transact with someone in a network, you can always verify your own actions and the actions of the other party. So it doesn't remove the need for trust, but you have to place your trust in the network, in all the peers in the network, and the cryptographic algorithms that govern the network. And then there's another interesting property. That is the immutable nature of blockchain networks, meaning that if I put a transaction in, there is no real way that transaction can be maliciously changed. If I would transfer some element of value, you cannot go back and cancel that transaction once it is confirmed by the network. And these are some interesting properties. But there's always a catch-22. This is, I think, a great quote from one of the co-founders of Ethereum, that blockchains by themselves are far less efficient computer and database than technology we've had for over 4 decades. Blockchain is expensive. It's expensive, and it is not as efficient as your traditional database. So you have to be really careful to map your problems or to your real-world scenarios to a blockchain solutions, because this is a big catch-22. What's very interesting is blockchains by themselves. So right now there are a lot of technologies and a lot of research is being done to improve the performance of these blockchains. But what's also happening is that this whole ecosystem around blockchain technology is emerging in support of this technology. So for a lot of actions, for a lot of things that don't make sense to put in the blockchain, there's this whole ecosystem emerging around it that works together with these blockchain networks. And that's where Streamr and Bloxs are focusing on. So, use cases. I just want to map a number of possible use cases when it comes to blockchain, and there are a lot more, but these might resonate here. For instance, when we talk about asset lifecycle and history, and Johan will be talking more about this, especially if you have an asset that has either shared ownership or may transfer ownership throughout its lifetime, would it be possible to have this shared environment that nobody really owns, but everyone can cooperate in to track what happened to the asset, all the events that happened to it, but also register the ownership of this real-world asset? Then there's supply chain. In this case, similar. You have multiple parties that might have some conflicting interests, but they're working together towards a common goal. Would it be possible to track the ingredients, where things came from, the conditions on how the ingredients were made, and track that in this shared, immutable environment? Temperature-controlled supply chains or cold chains might be a very good target for this, where you can use the concept of smart contracts to automate payment, for instance, when certain temperature bounds are being reached. And then there's the more abstract notion of how can we work with data? Can we track the quality of the data that we're collecting? Can we track the conditions that data was collected under? There's a lot of research being done into can we create digital fingerprints of data streams? If we can do that, can we claim ownership of certain data streams? I'm the one that produced that. That's my data. And if we can claim that, can we potentially monetize that data? So these are just a couple of examples of potential use cases. Now I want to hand it over to Henri from Streamr. We started working together a couple months back, and it's been a blast. I think they have a really great vision for the future. So please welcome Henri.
Thanks, Michael. Can you guys hear me? Yeah. And thanks to OSIsoft for inviting us here. So I'm Henri, CEO of Streamr. Let me kick off by asking you guys a couple of questions. Now, hands up, and be honest here, who's collecting data that does not get used to its full potential? I know we are. Yeah, I can see a lot of hands here. Okay, hands up if you think you could improve your business by getting access to some data that you're currently not getting. Again, a lot of hands. Okay, last question. Hands up, is anyone here sharing data across organizations to get more value out of that data? Still hands, but not too many. Okay, good. You should find this presentation quite interesting. So let's begin with the value in data. The total value of data consists of internal value and external value. By internal value, I mean benefits that you can get from your data by using it within your organization. The traditional case, right? By external value, I mean value that someone else sees in your data and is therefore willing to either pay you for it or turn it into something more valuable for yourself. Now, as OSIsoft customers, you already have excellent tools for extracting the internal value in your data. That's great. You're covered for that part. Now, Streamr is creating complementary technology that allows you to tap into the external value of data. Let me show you what that means. So here's a group of companies. They're collecting data into their own little silos and completely ignoring any external value in that data. However, let's assume for the sake of conversation that they would benefit from getting each other's data for whatever reason. Maybe they're part of a consortium or alliance, or maybe some of the companies are able to collect data that the others can't, or, you know, for whatever reason. Now, they would love to start sharing and monetizing data amongst themselves, but there's a bunch of obstacles on the way. First off, someone needs to set up and host the system, but nobody wants to take the initiative and bear the costs in time and money. The companies also need to agree on a technology to use, which is difficult because there are no open standards for this. Even if one of them takes the initiative, now the other companies feel uncomfortable joining this system created and owned by this leading company. This is an unequal situation where the leader has too much power and too much control over the system. Even if the companies can overcome these problems, they're still facing complicated contracts, data licenses. They need to figure out payments and accounting and all that hassle. Now, for companies like yours, whose core business is not data monetization, there's just too much friction in getting started with this. And yet, as you know from your work with OSIsoft, there can be huge value potential in data. So we're kind of stuck, right? So we're using the power of blockchains and peer-to-peer networks to solve this problem. So Streamr is a real-time data network. It's a distributed data fabric that transports data and payments between participants. It's a neutral, common ground for machine-to-machine communication, even across organizational boundaries. It's open source and aims to be an open standard for sharing and monetization of real-time data streams. Each party is equal in power, and the system is collectively run by the participants. There are no centralized points of control, and there are no middlemen. The system can scale from a private consortium deployment with a handful of participants, such as the one shown here, up to a global open network where anyone can join in. On top of this base layer is a marketplace, also co-owned and co-operated by the participants. The marketplace allows you to buy access to data streams from other organizations or put your data up for sale. Data licenses are implemented as smart contracts on the blockchain, which means that payment and access control are built into the system and enjoy the strong security properties of blockchains. To give you some ideas about how to apply this to your field of business, let's look at some use cases. So, okay, hands up if anyone here operates a fleet of mobile assets, cars, trucks, trains, ships. Okay, good. Your vehicles, they're moving around, roaming the world, and while doing so, they can measure things. Not only things related to the act of transportation itself, but also the environment, right? So, are you selling road condition data to the road authorities? No. Are you selling mobile network coverage data to telecoms? What about weather and pollution data to other drivers? Or driving habits? Imagine the savings if you could share metrics with insurance companies to prove just how safe your drivers are. So as you can see, transportation generates a lot of data that often remains uncollected. Sometimes because the internal value might be low, and the external value has so far been difficult to monetize. Another example, robots in a smart factory. Now, the robot manufacturer would love to get their hands on data from these real-world field deployments of their robots, perhaps to create better machine learning-based predictive maintenance algorithms. As you know, AI and machine learning typically get better with more and more and more data for training. Now, there's a problem. So this is partially sensitive customer data, and obviously the robot manufacturer can't just go spying on their customers, right? So instead, they could incentivize the customers to share the non-sensitive part of that data and be automatically compensated for participating. The money spent on buying this raw data from the customers is easily earned back by being able to develop improvements to the robots, to the predictive maintenance, and other added value services unlocked by getting access to this previously inaccessible data. One more example, quality assurance of perishables during cold storage transit. Now, this is actually an example that could involve not only the Pi system and Streamr, but also the smart contracts perhaps developed by the Bloxs guys, the next speaker. So, here, the transport company, the carrier, is responsible for keeping the temperature in the container within certain limits. If they fail to do so, they could be automatically penalized and the owner of the goods compensated. Wouldn't it be awesome if this required zero human involvement to resolve this kind of dispute? Here's how it can be done. So the carrier places a stake into a smart contract, a deposit to guarantee that the temperature limits are not violated. Then an inexpensive IoT sensor is placed into the container, which reports back readings to the Pi system and to the Streamr network. Now, if a violation is detected, the smart contract gets notified and it automatically slashes the deposit placed by the carrier and reimburses the owner of the goods. This data would actually be also interesting to third parties, such as import authorities or even the end users buying the food from their local supermarkets. So here comes the amazing part. So as you might have already guessed, working together with OSIsoft, we've already integrated the Pi system with Streamr. Now, the integration is still experimental, not yet a full product. But it means that everyone here running the Pi system could easily start trading data with others. In fact, it will be as easy as simply switching on the feature. So what's our proposal to you today? So if this presentation sparked some ideas about use cases in your line of business, please get in touch. OSIsoft and ourselves would be happy to work with you, but we do have limited places for these fascinating pilots. So there's a bunch of us present here today at the venue. Could all the Streamr guys please stand up and wave their hands? Okay, great. So find these guys or myself or Michael and have a chat. You can also find us online at streamr.com or on Twitter, Telegram, and Reddit. We are data done differently. Thank you very much.
Thanks, Henri. Now I'd like to ask Johan up on stage. Johan from Bloxs, based in Amsterdam, which is very close to my hometown. We've also been working together for a couple of months now, and it's been a fascinating journey.
Thank you, Michael. Thank you, Henri, for your wonderful presentation. My name is Johan Mulder. I'm co-founder of Bloxs. Together with Marco and Peter, we founded the company in 2017. We were working in the Microsoft IP world, and we were sharing common grounds around cryptocurrencies and other related subjects to the blockchain world. We really liked the actual foundation behind it, the real blockchain technology, the distributed ledger technology, and we also looked into the gaps that we saw between what's actually going on in the real world and what we can do on blockchain. So from that idea, from that point, we started building our own company, focusing on delivering that kind of products. So our main product is the Bloxs blockchain integrator. We use that product to actually build that bridge between what you want to do in the blockchain and what you already have as a company or as a consortium. So we are trying to offer a one-stop shop for a full end-to-end integration. That means that we offer consultancy, we offer the software, we offer the infrastructure as well. So you don't have to think about any other suppliers if it comes down to implementing your own blockchain implementation. So our product is based on Hyperledger. Is there anyone in the room who has heard of Hyperledger before? Okay, good, good. Hyperledger is a proven technology developed by IBM, Intel, and the Linux Foundation. It's an open source platform that allows you to build your own permissioned blockchain. A permissioned blockchain is a kind of implementation for blockchains where you have more control about who's going to have access to your blockchain. There are also open versions of blockchains. That means that anyone who has access to the internet can actually use the blockchain. Well, we're focusing on a more permissioned level there because we want to make sure that we can actually have the blockchain itself in full control. So that means that companies can build their own blockchain implementations without worrying about unauthorized access from the outside world. If you want to do it, of course, it's possible, but yeah, it's not necessary. Well, the simple fact is that Hyperledger itself is a full tool set. It's used by IBM itself, for instance, as well. So they, well, they maintain it, they improve it, and they actually make sure that everyone is able to use it according to their standards. And it means also that you, based on the open source nature of the product, that it's going to be maintained by hundreds of developers trying to improve the solution. So that means that the foundation itself is going to be is very, very solid. In last April, Bloxx and OSIsoft had a presentation in San Francisco as well on the Pi World. And on that presentation, we also discussed the use cases around blockchain and the Pi World. And we came up with the idea of putting it into a perspective, and the perspective here is the asset lifecycle management, in which we see a lot of things going on. We see a lot of different parties involved with different interests, with different maybe conflicting interests, but they all share the same thing, is that they are a part of the lifecycle of assets. For instance, an engine is produced, manufactured by a manufacturer, then it's going to be shipped, it's going to be commissioned, it's going to be used, it's going to be serviced, and then it's going to be put out of commission by either recycling it or putting it into scrap. The whole process around an asset can be quite cumbersome if it comes down to sharing data, storing data about the asset, but also try to leverage the data among different parties. And that's why we introduced a number of use cases connecting the Pi World into the blockchain by using the blockchain integrator. There are a lot of aspects that are relevant here as well when it comes down to trust, and that's why we want to use the blockchain as well, of course, because we're still looking into the fact that we want to store data in an immutable way. We don't want to change it anymore. We want to detect any tampering from different parties, etc., etc. So that's why we introduced this solution. The blockchain itself is in the middle, and that means that you can imagine all data involved is going to be connected to the integrator. That means that any party involved by the asset lifecycle management has its own rules in regards to accessing data or writing data to the blockchain. And the good thing about that is that you're still in full control within the consortium in which you're going to roll out the Hyperledger blockchain. So that's what we try to achieve by using the proof of concept there. Another interesting part there is that we try to leverage the concept of channels, which is also a feature of Hyperledger. Hyperledger introduces channels to actually channel your permissions and also the data streams that are involved on the blockchain. That means that, for instance, an owner of an asset can have access to all the data streams during its entire life cycle, but for instance, a guy who is in charge of servicing the asset only gets the relevant access to in regards to maintenance, running hours, etc., etc. A shipper, another example, only gets access to where the asset is on which ship, on which truck it's currently transported towards the customer. So having a full control on that particular part makes it also very trustful for any party involved, and especially for the owner of the data, who is still in full control on who's going to have access to what data at what time. Within our solution, we build a role-based access control system. That means that you can have full control on who's going to have access to what. This is part of the trust factor that is not only in the blockchain itself, but also on the user level. So what's next? Well, we're looking into a world that is going to be explored like the internet. In the early days of the internet, we didn't have a clue about how we're going to use the internet. And the same things apply to the blockchain. So what we're looking for is trying to find the business cases that we want to use to apply the blockchain technology for in regards to the Pi World. in that case, we also focus into the OSIsoft community part. That means that we try to build consortiums with different parties involved with a shared interest on certain type of assets, certain type of data streams, and we try to combine them into one pilot that makes sense to all the parties involved. And we see that the integration between OSIsoft and blockchain is pretty important there. Therefore, we already built the use case, and we, like Streamr, we built our own connector for OSIsoft to communicate with the blockchain. That means that it's already possible to store data from the Pi world into the blockchain and also get the data back from the blockchain. And that's well, that's a first start, of course, but you have to start somewhere. So that's the place where we can actually start picking up. Okay, what's next, right? So what are we going to do with the data? What are we going to do with those registrations? Are we going to get them back and try to run analytics on it, or are we going to use smart contracts like Henri mentioned? Are we going to put in some monetization factors in it too, as well? So, and last but not least, where's the added value? So why do you want to store the data into the blockchain? And that's a question that is, that still counts for everyone, and I think the question will remain there until for the upcoming years. And so we have to find a way how we can actually get the added value from the blockchain. But by having this product, by having our own integrator, we actually, we have the foundation already there. So that means that we have a head start, so we can actually start building our own ideas on top of the blockchain in conjunction with Pi world. So unfortunately, I don't have the time to show those demo videos I presented in San Francisco. But if you're interested, then please come by. I can show them to you. They're also on the website of the Pi world. I think they're usually, I think you still can find them. I'm not quite sure. They're still there. Great. Yeah. So if you have any interest in blockchain, and if you want to put it into a permissioned blockchain, and you want to share data within your community, please come by and let's have a further chat on how we can make that happen. Thank you very much.
Thank you, Johan. I think we have enough time for some questions. Henri, if you want to stay on stage. Henri, if you want to. Of course. Right? Are there any questions or comments or discussion topics? Let me get you the mic.
Hi, Jean-Michel Bryans, Veradia. A quick question for the access limited version of blockchain networks. Who is managing the access?
You mean the access to the actual blockchain?
Yeah, because you mentioned that with Hyperledger you can limit or restrict access to data. Who's managing this part of authorization? Is it a central authority or?
Yeah, you start with a central authority. So from a community, you start up with building your own roles and users that are going to be involved. And within those roles, you can actually, operate as a party or as a consortium. Yeah. So there is a centralized way to control access to all the data. Yeah.
Thank you.
Any further questions? Comments? Oh, in the back.
Hi, I'm Martin Handels, Rollo's. The first presenter actually said the performance limitations of a technology like Ethereum. So in my mind, the only thing you could do with blockchain now, other than cryptocurrencies, is smart contracts, right? I don't see how an open platform is going to store all this data encrypted and then do analytics on it and then push it back into Pi. I know everybody likes to put its product in the center, but for me, like in this audience, Pi would be in the center and blockchain would just be something around it. Because it's my primary medium for storage, and it's also the primary medium I'm doing analysis on right now. So for me, I see a lot of slides, and I don't see what it does now for me. So maybe one of you can elaborate.
Well, I can comment on that, and maybe you can
Sure.
follow up. So we do operate in the Ethereum ecosystem that you mentioned, but that's the whole point of building Streamr. Like, it depends on the use case. If you have a lot of data, if you have a lot of real-time data, for example, coming in from IoT sensors or whatnot, you do not want to put those onto the blockchain because it's not scalable, it's too expensive, it doesn't make any sense.
But why do you mention it then? For predictive maintenance, analytics, that's the problem.
I'm getting to it.
Okay.
So in Streamr, you do not put the data into a blockchain. You put it into the Streamr network, which is a peer-to-peer network, but not a blockchain, right? It's like a companion network for a blockchain, or a data layer on top of the blockchain, if you will. So we can use things, for example, smart contracts for data licensing, and there's interaction between these layers, but the data itself never goes onto the blockchain. This is how you can have scalability and also have benefits of the blockchain working kind of in the background. And you can have some of the same benefits, such as decentralization on the data layer, but you're not restricted by the scalability limits of the blockchain itself. For private blockchains, it's a little bit different, and Johan can comment on that.
Yeah, it is a little bit different, but also pretty similar, because what we're doing actually is storing just the right information on the blockchain, but any large sums of data, like for instance test runs or any data that you're going to store in event frames, that's a pretty common thing to do in the Pi world. We don't store that kind of data on the blockchain. We only make a reference to it, and we use algorithms to secure the integrity of the data between the blockchain and what's still going on the Pi world.
I think you're grossly underestimating your scalability, but that's my... we'll talk after. It'd be interesting to see how you think you're going to solve that. But thanks. Great presentations, by the way.
Thank you.
So just as a personal comment, I think it's great if we're very critical to this technology. I mean, there's a lot of hype around it, and you have to be critical. And I think a number of use cases where this really makes sense, but it's not a panacea. I mean, it's not going to change everything, right? So, but it definitely has a number of use cases that make real sense, and that's what we're exploring together. Any further questions, comments? Please, if you think of anything, come up to us.
Yeah.
Oh, are there questions?
No, there was this nice sound coming. Like,
oh, okay. This is it. Thank you so much for coming. Enjoy your lunch, and please find out if you have any further comments and questions. Thank you.
Great.
Thank you, guys.